One of the things that we get really good at with identities is having to recognize when you have either the right-hand side of an identity or the left-hand side of an identity. And in this case, in part A, we have cosquared of an angle minus sine squared of an angle. So one of the things that you can do is you can say, well, if this is alpha or theta, and that angle is the same, do I have a formula anywhere that's cosquared alpha minus sine squared alpha? So if you look at your formula sheet, you might notice that that's one of the cos 2 alpha formulas. So what we can do is we can take that expression, and we have the right side of the formula, and rewrite it as the left side of the formula. So here's our alpha, alpha, alpha. And since that formula is equal to cos 2 alpha, we get cos of 2 times pi over 4. You can now multiply 2 times pi over 4 and simplify it. That just becomes cos of pi over 2. What is cos of pi over 2? Unit circle, x coordinate, 0. Now, in this question, because they gave us pi over 4, and pi over 4 is on your unit circle, you could have figured this one out directly. Like, if I wanted to evaluate this directly, I say cos of pi over 4 is root 2 over 2. So this would be root 2 over 2 squared minus root 2 over 2 squared. And that might also be obvious that that's 0. But this question asked us to first write it as a single trig function. That's right there, a single trig function. And then evaluate if it's possible. The same thing in B. We could evaluate this already, but we first want to see if we can write this as a single trig function. Now, if I put alpha here and alpha here, I have 2 tan alpha over tan squared alpha minus 1. And when I look at my formulas with tan, it doesn't match up, because my formula with tan says, and I'll write it up here for you, tan 2 alpha is equal to 2 tan alpha over 1 minus tan squared alpha. And what do we have? We have tan squared alpha minus 1. So they're close, but not quite the same. And this is one of the skills that it's happened in grade 11, and maybe you're getting to the point where you see it right away, in that when you have the same thing with a minus sign just switched, like this is tan squared minus 1 and this is 1 minus tan squared, you can factor out a negative to match it up. So what does that mean? If I take my 2 tan pi over 6, and on the bottom I factor out a negative, that would make my 1 positive and my tan squared negative. Some things about negatives and fractions. If you have a negative in a fraction, okay? So if I have, in this case, the negative on the bottom, that negative on the bottom is same as having a negative on the top. It's the same as having a negative out in front. All with fractions and a negative, all of those mean the same thing. So right now I have a negative on the bottom. I am going to say that's the same as having a negative out in front of this whole fraction. And now I have inside the brackets matching up perfectly with the formula for tan 2 alpha. My alpha is pi over 6. So I get negative tan 2 times pi over 6. 2 times pi over 6, you can simplify that. To negative tan pi over 3. That's on your unit circle. It's just equal to negative root 3. Now again, this one asked us to write it first as a single trig function. That's what we've done when we got here. We have a single trig function, and then evaluate. However, if this question just said evaluate, you might say, you know what? It's easier to just apply it right at the beginning. I know that tan of pi over 6 is root 3 over 3. I'll plug that in right away and work from it from there. And that would be fine. So generally, to avoid that on an exam, they choose values that aren't on your pi plate. So I'm going to do a part C and a part D on this one. So in part C, I'm going to say, I want you to evaluate, that would be the instruction for this one, evaluate 1 minus 2 sine squared of pi over 8. Never seen a pi over 8 before. So how do we do this? Well, we have to look through our formulas. Does that match up with any of the formulas that we have? Yeah, it's a cos one, right? Cos 2 times alpha. And if I do 2 times pi over 8, what does this become? Just pi over 4. And that is on your unit circle, so now we can evaluate it. Whereas at the beginning you weren't able to evaluate, now you are. Make sense? Okay? One of the things that we do when we learn things is our experiences cause us to think of certain things. Like we see something, for example, I was training you this morning on, do you recognize this as a triangle question? The question says what quadrant and gives you an angle so you can draw a triangle. So one of the things we learn through experience is recognizing certain types of questions. From this last section that we did right before this, I was teaching you pi over 12 questions. And so when you see a pi over 12, your brain is going to naturally think, hey, that's a pi over 12 question. So I'm going to give you a question that looks like a pi over 12 question. Why does it look like a pi over 12 question? Well, I hope that's obvious. Because there's a pi over 12 in it. Now, pi over 12 questions on exams are generally 3 marks or 4 marks. This has pi over 12 twice, so if you use that technique on an exam, it would probably be 6 or 8 marks. Whew, because it's a lot of work, right? You have to find the 2 angles that add or subtract to that pi over 12, then use your sum and difference formula, and simplify it, and this would have 2 of them. But this question has come on exams before, and it's only out of 2 marks. So if you use the technique of a pi over 12 question, you could still get it right. You will just do 4 times as much work as you have to. Okay? And this is why I say we need to have our formulas memorized so that when you see 2 sine alpha cos alpha, your brain also triggers you to think about the sine 2 alpha formula. Because the pi over 12 is quicker to recognize, so your brain might immediately go to a pi over 12 question. Whereas in this one, if you say, hey, we have a formula for 2 sine alpha cos alpha, it's equal to sine 2 alpha. And if I multiply 2 times pi over 12, I just get pi over 6. And sine of pi over 6 is 1/2. Okay, try 4, 5, and 6.